In this video, I'm going to talk about geometric series. So I'll start off with what is a geometric series, explain what that is. I'm going to talk about the equations which we can use to work out various things in the geometric series. Same things that we had in our arithmetic series, how to find terms, how to find the sum of terms. And then I'm going to talk about the sum to infinity for a series where the modulus of r is less than 1. So it's a slightly different thing specific to geometric series, which I shall talk about specifically. Okay, so to get started, what is a geometric series? So a geometric series is a series of numbers whereby instead of always going up by the same amount, the term to term goes up by the same ratio. So for example, we could have 1, then 2, then 4, then 8, then 16, and so on. Okay, so we can see in this time that the amount it's going up is not by the same addition each time like we had with an arithmetic series, but this time it's the same ratio. So in this case it's multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2, multiplied by 2. Okay, so for a geometric series you need to have this multiple which is always the same. That's called the common ratio. Okay, and in this case the common ratio r is 2. So the next term would be 32, then 64, and so on. Okay, so that's how that works. Again, we use the a to represent the first term. Okay, so in this case, a is equal to 1. All right, we can have another example here. So we can have one where the series goes down. So I could start, for example, with 16. And then I could find, say, 3/4 of that. So that would be 12. And then 3/4 of that would be 9. And then 3/4 of that, and so on. Okay, so in this case, the common ratio here, I would find 3/4. So I'm going to say 0.75. So if I did 16 multiplied by 0.75, I get the answer of 12. And then 12 multiplied by 0.75. I would get the answer of 9. So I can say that this time the common ratio r is 0.75. If I wanted to, I could say r is 3/4. Okay, so both of these are geometric series because they have a common ratio. So each term you can find what the common ratio is by working them out. So to find the common ratio, you can just divide any two terms in the series, the greater one by the one preceding it. So to find r, you can divide two terms. So I could do u3 divided by u2. I could do u2 divided by u1. I could do u7 divided by u6, and so on. Okay, any of those ways would work. So in the first one, I could do 8 divided by 4 is 2, 16 divided by 8 is 2, 4 divided by 2 is 2. In the second one, I could do 12 divided by 16 is 3/4, 9 divided by 12 is 3/4, and so on. Okay, so what I'm going to talk about next is the equations which are used. So I've written the equations down here. So this is to work out the term. So here, this is the nth term. This is the first term. R is the common ratio. And then n is the term number. So if I went back to my original sequence where it was 1, 2, 4, 8, 16. So let me just write that out again. So 1, 2, 4, 8, 16. If I want to find the 10th term, then what I would do is I would do u10 is equal to, and then the first term, which was 1, multiplied by the common ratio, which was 2, and then to the power of 10 take away 1. So that would be 2 to the power of 9, which I can work out here, 2 to the power of 9, 512, and then multiplied by 1. So that would be equal to 512. Okay, if I wanted to work out for the 10th term for the other one, I would do the same idea. I would just start with A as 16, and then I'd start with R as 3/4 or 0.75, and I'd work it out in exactly the same way. Okay, so the other equation I've got there, this one, that is to find the sum of a certain number of terms. So in a similar way to we did with arithmetic sequence, I could imagine I had to find the sum of those 1, 2, 3, 4, 5 terms for the first one. So I'll do it by example again, and I'll add the first 5 terms together, and then we'll use the equation. So if I want to say, so that can be part 1 and then part 2. Find the sum of the first 5 terms. So I can do it the normal way. We'll just adding them up together to show you that we get the same answer when we do it both times. So if I do 1 plus 2 plus 4 plus 8 plus 16, then that's going to be 24, 28, 30, 31. Okay, so I should get the same if I use the equation. So the sum of the first 5 terms, S5, should equal to A, which is 1, and multiplied by 1 minus 2 to the power of 5. And then that needs to be divided by 1 minus 2. Okay, so 2 to the power of 5, 2, 4, 8, 16, 32. So that's going to give me 1 minus 32 over negative 1. So that's going to give me negative 31 divided by negative 1, which is indeed going to give me 31. So we can see that that's worked out just fine. Okay, so the last thing to talk about here then is the sum to infinity. Now the equation is written there. Just make my page a bit bigger. So equation is written here like that. Sum to infinity, and it says after it, the modulus of R has to be less than 1. So what this means is that our series needs to be divergent. If we look at the series I had here, the first one where it says 1, 2, 4, 8, 16, you can see the numbers are getting bigger and bigger and bigger and bigger and bigger. So as the series goes on, the numbers are going to get greater because R is 2, which is greater than 1. Whereas on the second series I gave, 16, 12, 9, you can see that those numbers would get smaller. So next I would work out what 3/4 of 9 was. So if I did 9 times 0.75, I'd get 6.75 and then 5.625, and I could keep on going, and you could see these numbers get smaller and smaller and smaller. Okay, and eventually it would head down to be pretty much close to 0. Okay, and we get smaller and smaller, 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 smaller as we go along. So you can imagine that as we add the numbers together, we keep on adding a smaller and smaller number, and over time, that number is going to get closer and closer to 0. So if we're imagining we're doing a sum to infinity, so we just had the whole sequence running out forever, the number at the very end would be pretty much 0. So when we add all the numbers together, we just keep adding a smaller and smaller and smaller amount, and so our sum would end up tending to a limit. So if I was to sketch it out, so with the sum for infinity, when R is less than 1, so between 0 and 1 in fact, it's going to reach a limit. So I can sketch a graph, and it's going to start off, and it's going to add up, and it's going to go something like that, and we can work out a limit. So this value here, that would be the value that we're trying to find. So by using the sum to infinity equation, we can actually find out what that value is. So that's the principle of it. So we work out the sum to infinity. So if we want to work out our sum to infinity for our equation here, we would need to know, so let me just write it out again. So we're going to find the sum to infinity for the series, and then it was 12, 16, 12, 9, dum 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 dum. Okay, so our equation for sum to infinity is equal to and then it says it's a over 1 minus r. Okay, and r has to be, or the modulus of r has to be less than 1. So it can be negative, which just means that the values would oscillate up and down, positive, negative, positive, negative, positive, negative, but they would still tend to be 0. So you'd still end up adding on smaller and smaller amounts. So it would still make your limit, just like in my diagram. Okay, so in this case, a is equal to 16, because that's the first term, and r is equal to 12 over 16, which would also be equal to 9 over 12, which is equal to 3 over 4. Okay, or 0.75. So to work out my sum to infinity, it would just be 16 over 1 minus 0.75. So that's going to be 16 over, I'm going to write that as 1/4, just write it as a fraction. So therefore 16 divided by a quarter is going to be 64. So if I keep on adding the terms together, I'm going to get closer and closer and closer to 64. So first of all, we'd add 16, then add 12 on, so it would be 28, then add 9, would be 37, then add a smaller amount, and it would get closer and closer and closer to 64, the more as I went along. All right, so that's how we'd work out the sum to infinity, and that's basically the procedures that you need to work out geometric series.